Session 9.1 Two Proportions. Chapter 7 We know how to construct the confidence interval involving four population parameters. We have the population proportion, population mean, population standard deviation, or variance. Chapter 8 We know how to do the hypothesis testing with the same population parameter. We have proportion, mean, standard deviation, or variance. Both chapters only involve the method dealing with the sample 1 populations. Okay, chapter 7, chapter 8, we only work on one population. For the chapter 9, we will learn how to do the hypothesis testing and confidence interval, but this time we'll be involving two populations. So we have two parts in here. First part, we're gonna talk about the hypothesis testing. We are still using the X step, and the last one will be using the confidence interval. And for these sessions, we'll be focused on proportions. Look at this example. In the 2009, I have the first population in a survey of 400 college students. So I know that my sample size will be equal to 400. More than 85% of the students who think Facebook is cool. So the 85% talking about the 400 sample size in here. So this is gonna be your sample proportion. In 2013, the second population. In a survey of 300 college students, this time my sample size will be equal to 300. More than 90% of the students who think Facebook is cool. So this is talking about the sample proportion. That will be equal to 0.90. Can't you conclude that the proportion of the people who think Facebook is cool was greater in 2013 than in 2009? So you're gonna see these questions, we involve two populations in here. So if you want to do the hypothesis testing, we need to apply the chapter 9 methods to compare the result. So for the chapter 9, the first step, I need you guys to remember that. First step, you need to write down which one is going to be your P1, which one is going to be your P2. The P1 here, this is stand for population proportion, okay? Population proportion. So I'm going to let in 2009, will be my population proportion, P1. And I will let in the 2013, this is going to be my population proportion, P2. Okay, after you let the P1 and P2, you could change the notation in here. Since this is gonna be my P1, I will use the N1 equal to 400. And the sample proportion, I will change to the P1 also. Okay, sample proportion 1 equal to 0.85. And in the 2013, this is my P2. So we're gonna change it to the N2 here. N2 equal to 300. And this guy, that will be the sample proportion 2 equal to 0.90. So you're gonna know all the notation with the 1, this is stand for the population 1. And all the notation with the 2, this is stand for the population 2 in here. Now we're gonna write down the original claim. So with the claim statement, can you conclude that the proportion of the people who think Facebook is cool was greater in 2013 than in 2009? So you're gonna see the original claim here. It should be P2 greater than P1, right? Because my 2013, this is the P2. So from the claim statement, we could write like P2 greater than P1. But I'm gonna put it on like this way, P1 less than P2. For the population 1, try to put it on your left hand side. Instead of putting P2 greater than P1, I would say P1 less than P2 here. Okay, after you have the original claim, and you know this is gonna be go to your alternate hypothesis. So I have an alternate hypothesis P1 strictly less than P2. Now figure out your null hypothesis. That will be greater than or equal to P2 here. And you know this is going to be your left tail test. Okay, right? Similar idea with the chapter 8. But here, I want to show it to you guys. I don't have to let the P1 will be my population proportion in 2009. P2 will be the population proportion in 2013. I could do it another way. I could let P1, that will be the population proportion in 2013. P2, that will be my population proportion in 2009. Okay, it doesn't really matter, but you have to write it down and let me know which one is your P1, which one is going to be your P2. But if I let it differently, you could see my original claim right now that will become P1 greater than P2. Okay, and my alternate hypothesis is going to be greater than my null hypothesis that will be less than or equal to. According to my alternate hypothesis, I will be working on whitetail. You guys see the difference, right? If I let it differently, my original claim statement, null and alternate hypothesis, left tail or whitetail test is going to be totally different. That is why it is so important. You have to tell me which one is going to be your P1, which one is going to be your P2. And this is going to be part of your credit. So remember, highlight this part, homework and exam. For the chapter 9, first step, let me know which one is going to be your population 1, which one is going to be your population 2. Okay, requirements. The sample proportion are from two simple random samples that are independent. So requirement, two simple random samples and are independent. Independence means the sample size in the 2009 that is independent from the sample size to the 2013. Okay, these two are totally not related. So this is called independent. And also, we do have at least 5 success and at least 5 failures. So we could do sample size times the sample proportion in success greater than or equal to 5. Sample size times the sample proportion in failure has to be greater than or equal to 5 in here. Okay, notation. So you know N stand for the size of the sample. Again, if this is working for the population 1, we're going to put the 1 in here. P1, that's a population proportion. X1, that's a number of success in the sample. So if I want to calculate the sample proportion, I could do X1 divided by the N1. Okay, number of success divided by the sample size. Sample proportion in failure, that will be the complement with the sample proportion in success. The corresponding notation apply to the population 2 also. The pool sample proportion is denoted by the P bar here. We have something new formula. We call this is the pool sample proportion. You could see the P bar. How you find out the P bar? Number of success, x1 plus x2, divided by n1 plus n2. And the pool sample proportion in failure, that will be the complement. Okay, just subtract from 1 here. Okay, the test statistic. Test statistic for two proportion. The formula is a little bit complicated. This is the P hat 1. That's a sample proportion success in the population 1. That's a sample proportion in success in the population 2. Then here, I'll be using the P bar Q bar, the pool sample proportion. Okay, I'm gonna show you guys how to use the formula for the first example. Since the formula is really complicated, I will let you guys use the calculator to find the test statistic. So on the homework and exam, I will specific write it down, use calculator to find the test statistic. So you guys could skip all this part in here. Okay, performing a hypothesis test for the difference between the two proportions using the p-value method. So just like the chapter 8, we have the p-value method, we have the critical value method. So first step, verify the requirement. Okay, number one, extract the information. First step for the chapter 9, write it down which one is going to be your P1, which one is going to be your P2. Hey, one more time. This P stands for the population proportion. Okay, this is talking about the population proportion. So if the section 9.2, you may want to put the mean 1. So that's a population mean 2 here. Okay. And then figure out what is your sample size, number of success, and also the sample proportion. And then original claim, you're gonna compare with two populations. Depends on your claim statement here. Know an alternate hypothesis. Same idea just like the chapter 8. For the chapter 8, we compare the population with the value. So we do have the numbers in here for the chapter 8. But chapter 9, we are comparing with two populations. So know an alternate hypothesis, that will be the complement. Not equal to, that will be to tail. Less than will be left tail. Greater than, that will be the right tail. And make sure you're gonna put the population 1 on your left hand side. Okay, population 2, that will be on your right hand side here. Number 4, compute the test statistic. So we have a complicated formula here. Again, I will show you guys how to use this formula for the first example, but other than that, feel free to use the calculator to find the test statistic. Number 5, distribution. I will use the left tail example. So this is a p-value method. This point, that will be equal to your test statistic. And we will use the test statistic to find the left tail area, which is going to be your p-value. So the proportion, we are working on the z distribution. How can you find your p-value? We'll be using the normal CDF, right? Normal CDF, lower value to upper value. And after that, we'll be using the p-value compared with your significance level. Less than or equal to, reject. Strictly greater than, that will be fail to reject. Final works, the same chart in the section 8.1, the 1, 2, 3, 4 conclusion. So this is the first part, perform the hypothesis testing using the p-value method for two populations. And follow this step, you could use your calculator to double check your work and also find the test statistic. Okay, second part, we're gonna talk about the confidence interval, just like the chapter 7. And for the confidence interval, we're gonna find out the difference of the population, okay, the difference of the populations. So we need to know how to find the margin of error. Remember this guy? This is called the critical value. You could review from the chapter 7 exactly the same step how you find out the critical value. And plug in here, find out the margin of error. Then construct the confidence interval. We always find the difference of population proportion. Okay, so the difference of the sample proportion plus minus with your margin of error. Remember for the confidence interval, they always tell you what is the confidence level. We were working on 90%, 95%, and 99%. But for the chapter 9, since we combine with the hypothesis testing, sometimes they may not tell you guys what is the confidence level. Instead, they will tell you the significance level. What is your alpha equal to? If you are working on the two-tail, okay? If you're working on the two-tail, the significance level, that will be the 0.05. That means confidence interval. That is 95%. Let me explain like this one. If you're working on the hypothesis testing for the part 1, we do have a two-tail. So two-tails talking about like this way. And if your significance level, that is equal to 0.05, this is talking about this two part in here. Sum of the area of the two-tail will be equal to 0.05. So think about it. What is the area in the middle here? Total area will be 1. 1 minus 0.05, which is 0.95. That means we are working on 95% confidence interval. So one more time, if they're working on the two-tail, they're given the significance level, you could just subtract from 1, figure out your confidence level. Okay, now look at another one. Let's say my hypothesis testing, we are working on left tail, okay, left tail. And they given the significance level, that's a 0.05. So that means the area of the left tail, that will be 0.05. But this is only for hypothesis testing. Hypothesis testing, we have a left tail, right tail, and two tail. But we call from the chapter 7. On the chapter 7, when we construct the confidence interval, we always have the two tails. We never mention about left tail, right tail on chapter 7. Right now, we construct the confidence interval. It's always two tails. If the first part, you're working on the hypothesis testing, that's a left tail, you need to make up the right tail as well. And the area of the right tail, that will be equal to the significance level. It's also 0.05. So now, look at here. The total area is 1. I'm gonna minus 0.05 minus 0.05. So the area in the middle become 90%. So if your alternate hypothesis with the significance level 0.05, that's for left tail or right tail, the confidence interval will be 90%. I want you guys highlight these two sentences in here. Keep in mind, if you're working on left tail, right tail, then you need to make up one more for your significance level. Calculate the confidence interval. If you're working on the two tail, the significance is 0.05, you could just subtract from 1, find out the confidence level in here. Okay, now let's try the example 1. We'll be working on hypothesis testing and confidence interval. This is the step how you guys use your calculator to find out the confidence interval for the population proportion. Example 1. In the year 2002, the General Social Survey asked 1343 employed people between the age of 18 and 50 whether they use a computer in their work, and 916 say that they did. So I do have the first population in here. In the year 2008, they asked the same questions of an independent sample of 615 people, and 465 say that they use a computer at work. Assume these are two random samples from the population of employed people. Can you conclude that the proportion of the people who use a computer at work was greater in 2008 than in 2002? Given the significance level would be equal to 0.05. First, we're going to verify the requirement. We have a two independent random samples, and we have a two category. We have the success and failure. So use a computer at work, that's considered success, and do not use a computer at work, this is considered as a failure. And we also have at least 5 individuals in each category. So it satisfies the requirement. Number 1, extract the information. Remember it was the first step for the chapter 9? We need to write down which one is going to be your population proportion 1, which one that will be your population proportion 2. So I just let the P1 will be my population proportion in 2002. P2, that will be the population proportion in 2008. Okay, now we're gonna find out this information. Try to read the questions one more time. Find out your number of success, sample size in 2002, number of success and the sample size in the 2008. Check your work. Okay, now we're gonna find out what is my sample proportion 1 and the sample proportion 2. So I will use the formula x1 over n1. You should get 0.682. Okay, try to find the sample proportion 2 here. Check your work. You should get 0.756. Okay, number 2, original claim. Find out the claim statement. The last sentence here, should be your claim statement. Can't you conclude that the proportion of the people who use a computer at work was greater in 2008 than in 2002? So what is your original claim? That will be P1 strictly less than the P2. Again, make sure you put the first population on your left-hand side here. Okay, what is your null and alternate hypothesis? This one should be go to your alternate hypothesis. And what is the null hypothesis? Opposite with this guy. So greater than or equal to. Okay, left tail, right tail, or two tail? That would be left tail. Step 4, test statistic. So first, we try to find the pool sample in success. Plug into the formula and let me know what is your pool sample in success. Okay, check your work. Now find out the pool sample in failure. You should get this guy. Okay, plug into the test statistic formula. We already found it out the sample proportion 1 and the sample proportion 2. So we have the pool sample here. Plug it in and use your calculator. You should get negative 3.33. Okay, you could see this is really complicated using the formula. So that's why I let you guys use your calculator directly to find the test statistic. Okay. If you use your calculator, you should find the test statistics should be negative 3.34. Let me finish this example and I will show you guys how to use your calculator. Okay, number 5, distribution. We are working on the p-value method and we have the left tail example. So now the test statistic here, I'll be using the calculator this one, negative 3.34. So we want to use the test statistic to find the area of the left tail, okay, which is going to be your p-value. Okay, so p-value, this is the left tail. So we're going to be using normal CDF, lower value to upper value. Use your calculator, you should get this guy. With the answer carefully. This is 4.19, and then at the end, you should see the y -4. The y here is talking about times 10 to the power of -4. And this is the scientific notation. We could change back to the standard form. So that will be 0.0004 in here. Okay, number 7. Draw the conclusion about your p-value. We'll be using the p-value to compare with your significance level. Okay, so that will be less than or equal to. We will reject the null hypothesis. Okay, last one, conclusion. Think about it. Which conclusion you're gonna use? 1, 2, 3, 4. We're gonna go back to look at your original claim goes to alternate hypothesis. So either number 3 or number 4 conclusion, right? This is exactly the same thing. So either number 3 or number 4 conclusion. And then we reject it. So that'll be the number 3 conclusion. There is sufficient evidence to support the claim that make sure to copy the claim statement. I need complete sentence on your homework and the exam. Okay, now let's look at your calculator. You're gonna click on the stat, go to the test, and then we're gonna choose 2 population proportion C distribution hypothesis testing. Remember on the chapter 8, we'll be using the number 5 in here. 1 here, this is stand for 1 population. Right now we have 2 populations, so we're gonna put another 6 in here. Okay, x1, that will be 916, n1, x2, n2. And we have less than. So we're gonna choose strictly less than, enter. This is talking about your alternate hypothesis. Okay, alternate hypothesis is gonna be strictly less than. Go to calculate, enter. So first, you will have the test statistic negative 3.34. Okay, we're gonna want it 2 decimal space. This is 5, so you're gonna add 1 from here. So that's why we're gonna get the test statistic negative 3.34. And then the P here stands for your p-value. So p-value, we got 4.19 times 10 to the power of -4. And here, you're gonna see this is a 4.25. This p-value will be a little bit greater than our p-value. It is because when they use the test statistic, they will be using all the digits from here. But from our work here, we only use 2 decimal space of your test statistic. So that's why a p-value is a little bit off, but it's just a little bit in here. As long as you guys show me all your work, this is good. So using your calculator, you could find your test statistic and also you could check your p-value. Okay, second part, find the confidence interval. Okay, same questions and I want to find the confidence interval. So we have the formula in here. First step, figure out your critical value. For the alternate hypothesis, we are working on the left tail test. And given the significance level is going to be 0.05. Okay, remember that when we have the left tail significance is 0.05, we need to make up the right tail also. It's also the same significance level. So we are working on 90% confidence interval. Okay, so I have a 90% confidence level. Now we're gonna try to find out the critical value. So critical value will be equal to inverse norm 0.95. If you guys don't remember why I have a 0.95 here, please review the chapter 7, okay? Review the session 7.2, the first two examples. You should get the critical value 1.645 here. Okay, we got it, the sample proportion 1 and sample proportion 2 from the step 1. And also we have the N1 and N2. So now I'm gonna plug into the formula. Okay, I have the Q1 here. Q1 means 1 minus P1. Okay, Q1 is a complement with the P1. So I'm gonna subtract from 1 here using the P1. Same idea for this guy. Use the calculator, you should get 0.0353. Okay, after you have the margin of error, plug into this formula. You already have a p hat 1 and p hat 2. So plug it in all the information, use your calculator. You should get the confidence interval is between these two numbers. Okay, now look at the calculator again. So go to the stat, go to the test. We're gonna choose two population, proportion, C distribution, confidence interval. Enter. So plug in the number here. Let's go back. I have a 916, 1343, 465, 615. So I already have all this information. What is your confidence level? That will be 90. So I'm gonna put 0.90 here. Go to calculate. Enter. So you can see confidence interval will be in between these two numbers. You could see this one is a little bit off from ours. It is because the decimal space in here. If you try to get more decimal space for your critical value and the sample proportion, you should get exactly same with your calculator. Okay, so chapter 9 we combine with chapter 7 and chapter 8 together. Only difference is we are working on two populations. Okay, try another example. Example 2. Research conduct a study of smartphone use among adults. A cell phone company claimed that iPhone smartphones are more popular with whites than with African Americans. The results of the survey indicate that of the 232 African American cell phone owners randomly sampled, 12 of them have an iPhone. Of the 1,343 white cell phone owners randomly sampled, 135 of them have an iPhone. Test at the 1% level of significance. Is the proportion of white iPhone owners greater than the proportion of African American iPhone owners? So for the chapter 9, remember what's the first step? First step, let me know which one is going to be your population proportion 1, which one is going to be your population proportion 2. It doesn't matter which one you let it has a P1, which one let it has a P2, but you have to indicate it. So I will put P1 will be population proportion for the whites. P2, that will be the population proportion for the African Americans. And then figure out the number of success and also their sample size. Okay, check your work. Now, your original claim statement with the claim statement here. Is the proportion of white iPhone owners greater than the proportion of African American iPhone owners? So my white here, that will be my P1, greater than African American, that will be my P2. So P1 strictly greater than P2. And then the null and alternate hypothesis. Since this is a strictly greater than, that will be go to your alternate hypothesis. And how about your null hypothesis? That will be opposite with this guy. So that will be less than or equal to. Okay, left tail, right tail, or two tail? That will be right tail, right? Because this is a strictly greater than. Okay, for the test statistic, remember, you don't have to use the formula. Feel free to use the calculator for this session because the formula is a little bit complicated. Okay, let's try to use your calculator. So you're gonna click on the stat, go to the test, go down, this is the two population, proportion, C distribution, hypothesis testing. Okay, for my X1, we have a 135, sample size, X2, N2. And then my alternate hypothesis, that will be strictly greater than. Go to calculate, enter. So we do have the test statistic 2.36. Okay, 1 to 2 decimal space, and this is greater than 5. So that will be 2.36. And then this is gonna be your p-value. You could write it down and double check for it later. And you do have the sample proportion P1 in here. Okay, remember how to find your P1? You're gonna do X1 over N1. P2, that will be X2 over N2 here. Okay, your test statistic, that will be 2.36. Okay, distribution. We are working on whitetail test and we have the test statistic 2.36. So Z, this is a normal distribution and we have the whitetail. So we have the test statistic 2.36. Now we're gonna use our test statistic to find the p-value, which is gonna be the whitetail of area. So we're gonna use the normal CDF, lower value to upper value. Okay, use your calculator. We're gonna get 0.0091. Okay, so write it down here, 0.0091. And this value match with our calculator. Remember the calculator, when we find the test statistic, we also see the p-value. The p-value is also equal to 0.0091. Okay, now number 7. Compare with your significance level. Okay, compare with your significance level 0.01, which is gonna be less than, right? Less than or equal to. So that'll be reject. Conclusion 1, 2, 3, 4 conclusion. So we have original claim go to alternate hypothesis. So that will be either number 3 or number 4 conclusion. And we have reject. So reject, that will be the number 3 conclusion. There is sufficient evidence to support the claim that a larger proportion of the white cell phone owners use iPhones than African American. Okay, B, find the confidence interval. So again, we have the margin of error, the formula here. And then we have the alternate hypothesis. So first, you guys need to figure out what is your confidence level. So we have the white tail significance level is going to be 0.01. Remember, when you have the white tail, significance level is 0.01. So we're going to make up the left tail again. So the left tail area will be 0.01 also. So you should working on 98% confidence level. Figure out the critical value. If you don't know how I get this number, review your chapter 7, session 7.2, the example 1 and example 2. So critical value, you're gonna get this guy. Okay, now we're gonna figure out the p hat 1 and p hat 2 here. Feel free to use the calculator. Remember, on the calculator, we find the p hat 1 and p hat 2 already. Or just use the formula. You should find these two guys. So we have the critical value, we have the sample proportion 1, sample proportion 2, we have the sample size. And the Q1 here, this is going to be the complement with the p hat 1. So here I'm going to put 1 minus the p hat 1 here. Same idea for this guy. 1 minus the p hat 2. Use your calculator. You should get this one, right? The margin of error. Construct the confidence interval. Find out the difference of the population of proportions. So we have the p hat 1 and p hat 2 here, plus minus the margin of error. You should get this guy. Okay, let me use the calculator. So it to you guys how to get the confidence interval, and also I want to show you guys how to input to your calculator to find the margin of error here. So first, use the calculator to construct the confidence interval. We're gonna go to the stat, go to the test, go down. You're gonna find two population, proportion, seed distribution, confidence interval. So we have the x1, 135, n1, x2, n2. Significance level, we have a 98%, so 0.98. Go to calculate. Enter. So we're gonna get 0.009, which is gonna be 0.01 here if we want it up here. And here that'll be 0.0876. It should be matched with our calculations here. They also given your p hat 1 and p hat 2, so you could double check your work. Okay, now I want to show you guys how I plug into my calculator for my margin of error. So here I'm gonna do 2.326 times square root. Okay, you could see my square root here. I don't need to use the parenthesis. If you're using the TI-83, you may want to put one more parenthesis in here. So here I'm gonna do 0.1005 parenthesis 1 minus 0.1005 divided by 1343, and then plus 0.0517 parenthesis 1 minus 0.0517 cos divided by 232. Okay, make sure you go out. Make sure your square root it's gonna be including everything, okay? The square root is cover the whole things together and then enter. So this is how I got 0.0388. Try to put everything into your calculator in one format in here. Don't try to separate, do it like part by part. If you only take 2 or 3 decimal space, you may get a different number from your margin of error. Example 3. Among 343 women surveyed, 15 worked the graveyard shift. Among 294 men surveyed, 27 worked the graveyard shift. The samples are independent and were gathered using simple random sampling. Use the critical value method and a 2% significance level to test the claim that the proportion of women working the graveyard shift is less than the proportion of the men working the graveyard shift. Okay, first step, let the P1 and P2. So I will let the P1 the proportion of the woman. P2, that will be the proportion of men. Now, I want you guys to figure out these 4. The number of success and also the sample size. Okay, original claim. With the claim statement, tester claimed that the proportion of the women working at graveyard shift is less than the proportion of the men. So I know my P1 represent my woman. So P1 is going to be less than P2. And this is a strictly less than, so this is going to be go to your alternate hypothesis. What is your null hypothesis? That will be greater than or equal to. And this is going to be your left tail test. Okay, this is the critical value method. And step 1, 2, 3 will be exactly as same as the p-value method. And then number 4 distribution is going to be different. So we are working on the z distribution, so we have the normal distribution. And we're working on left tail test. Okay, left tail test with the critical value method. So first, figure out what is the area of the left tail. This is going to be equal to your significance level, right? So significance level is going to be 0.02. Now, use the area of the left tail, find the critical values. And remember that if this is a left tail, will your critical values be negative or positive or plus minus? That will be negative, right? So given the area, find out the critical value, we're going to use the inverse norm. Okay, inverse norm. The norm here represent the normal distribution. That will be the z. Use the calculator. You're going to get negative 2.05. Okay, so I'm going to write it down here. This point, that will be negative 2.05. Now, use your calculator. Find the test statistic. You will see negative 2.44, right? Since this is a critical value method, I want you guys to show me where is this test statistic located. Will be inside the critical region or outside of the critical region. So negative 2.44 should be smaller than this guy, right? So somewhere like here. If your test statistic is located in the critical region, we're going to reject or fail to reject. That would be reject, right? Reject the null hypothesis. Okay, conclusion 1, 2, 3, 4. So again, we have the original claim go to the alternate hypothesis. So either number 3 or number 4 conclusion, and then we reject it. So that will be the number 3 conclusion. On the homework and the exam, I need you guys to show me this picture. Okay, show me the area of the left tail or right tail or two tail. Show me the critical value, and also show me where is your test statistic located. Is in the critical region or is not in the critical region? Okay, B, confidence interval. We do have the formula for the margin of error, and then we have the alternate hypothesis is less than. So this is going to be left tail, and the significance level is going to be 0.02. So figure out what is our confidence level. Will be 90%, 92, 93, 94, or 99%. We have the left tail equal to 0.02, right? So meaning that I make up the right tail is also 0.02. So when you add it up, it's going to be 0.04. 1 minus 0.04, that will be 0.96, which is going to be 96% confidence level. So now figure out the critical value. Critical value, that will be inverse norm 0.98. You should get 2.054. Either use your formula or use your calculator. Figure out what is your sample proportion 1 and the sample proportion 2. You should get this too. Okay, plug into the formula. You should get this one. Right. Okay, after you figure out the margin of error, construct the confidence interval. Okay, you should get this one. The confidence intervals that will in between these two numbers. Okay, so for chapter 9, again, we combine chapter 7 and chapter 8 together, but we're working for two populations. You need to know how to do the hypothesis testing and also the confidence interval. And you need to show me all your work, so don't skip all of them, just use the calculator to give me the final answer. Okay, I need to see all this work on the homework and exam. That's it for the session 9.1.